This is a Fourier transform problem where the signal xt is given and we are asked to compute its Fourier transform. The first approach is to use the Fourier transform integral directly. Using this formula, you could compute the Fourier transform directly. However, this method is relatively difficult because it requires multiple integration steps. So instead of using direct integration, we want to use a smarter method based on properties and previously known results. The first thing you should do is sketch the signal. If we draw the signal, before minus 1/2 the signal is 0. After plus 1/2 the signal becomes 1. And between minus 1/2 and plus 1/2 the signal is a straight line with a slope equal to 1. So this is the signal xt. Now we want to compute its Fourier transform. Instead of directly transforming xt, we first differentiate it. Let the derivative of xt be yt. So dxt over dt equals yt. Now let's sketch yt. Before minus 1/2 is still 0. After plus 1/2, derivative becomes 0. Between minus 1/2 and plus 1/2, since the signal is a line with the slope 1, its derivative becomes 1. So yt becomes a rectangular pulse. Now recall an important Fourier transform pair. A rectangular pulse from minus t1 to t1 has Fourier transform 2 sine omega t1 divided by omega. Here t1 equals 1/2. Therefore yj omega equals 2 sine omega over 2 divided by omega. Therefore yj omega equals 2 sine omega over 2 divided by omega. Now remember, since yt is the derivative of xt, then the xt is the integral of yt. So we use the Fourier transform integration property. The integration property says if yt transforms to yj omega, then the integral of yt transforms to yj omega divided by j omega plus p y evaluated at 0 multiplied by delta omega. But the integral of yt is exactly xt. So xj omega becomes yj omega divided by j omega plus py 0 delta omega. Now we already know yj omega. The only remaining quantity is y evaluated at 0. To compute y0, substitute omega equals 0. But this gives 0 over 0, which is indeterminate. So we use Hopital's rule. Hopital's rule is differentiate numerator and denominator with respect to omega. The derivative of 2 sine omega over 2 becomes cosine omega over 2. The derivative of omega is 1. Now substitute omega equals 0, cosine 0 equals 1. Therefore, y0 equals 1. Now substitute everything into the formula. So the final Fourier transform becomes xj omega equals 2 sine of omega over 2 divided by j omega squared plus p delta omega. So in this example, instead of solving difficult integrals directly, we solve the problem easily using differentiation, rectangular pulse transforms, and the integration property of the Fourier transform. If you found this video helpful, don't forget to like and subscribe.